Our project name is VLabs7. Our team members are Crystal Rivera, Scrum Master and Front-End Developer, JuanRiano and Trongo, Front-End Developers, Daniel Gonzalez and JuanRiano, Back-End Developers. Virtual Labs allows students to access resources as virtual labs, mentoring, and certificate exams through a web interface. The problems that we wanted to address in our current version were decoupling of eFront inside Moodle, as eFront itself has the functionality we need, the delivery of RDP sessions through Java applets that have been phased out of all major web browsers, and the fact that our virtual environment was a mix of KVM and VMware, which needed to be unified. For our development effort, we used the agile methodology called Scrum. We divided the project in 5 sprints of 2 weeks. My task in this project was to implement a replacement for the Java applets previously used to deliver the RDP connections. We decided to use the Guacamole Server Gateway, an HTML5 solution for remote desktop access. During the development of the project, I was able to complete 9 stories that resulted in an implementation that delivered a working solution. The main use cases implemented in my solution were: open a Guacamole RDP session. This use case took most of the developing effort. To implement it, I had to develop an authentication plugin for Guacamole. Restrict hosts to which Guacamole can connect. This was done to prevent abuse of the system so that students could connect only to our virtual machines. Install Guacamole and Guacamole auth URL. To install Guacamole, you need to build it and then place configuration files in specific locations. I developed a script to automate the installation of both Guacamole and the authentication plugin. Stress test Guacamole and monitor the host server. VLabs needs to be able to establish at least 100 concurrent RDP sessions. I developed a script to monitor the server's resources and used it while the stress test opened 145 RDP connections to Guacamole. The Guacamole subsystem has 3 actors: the eFront module that requests the RDP connections, the administrator that sets the range of computers Guacamole is allowed to connect to, and the actual student using VLabs. To create an RDP connection, Guacamole gets a hold of the HTTP request, it extracts the parameters to construct a user context, validates that the remote desktop is within the permitted range, and then it creates a tunnel to try to connect to the requested host. The success of the connection relies purely on the validity of the credentials and host address. Virtual Labs is implemented with a 3-tier architecture. Guacamole is in the presentation tier, interacting only with other subsystems in the same tier. Those are eFront and the KVMs. The requirements for Guacamole are a dual-core processor with a 20 GB hard drive, 4 GB of memory, and an internet connection. The system must be running Ubuntu Server, Java JDK, Apache, and Maven. Guacamole does not store any data, as all it does is to open RDP sessions based on the information provided in the URL. Guacamole auth URL can accept encrypted passwords to protect them from eavesdropping. The password is disposed as soon as the connection is established. The authorization plugin hooks into Guacamole by extending and taking the place of an authentication provider. The plugin's main class is the authorization provider that creates the user context. The other two classes help with the issues of password decryption and validation of remote desktop address. Guacamole is always waiting for connection requests. When it gets one, it extracts its parameters to create a credentials object. Then, validates the host information against the permitted ranges. Finally, a connection object is created, and if all works fine, the connection will be established. At each point, if things fail, Guacamole drops the process and goes back to waiting for more connections. The main algorithms of the plugin are in the methods in charge of creating the user context and parsing the HTTP request parameters. The logic is straightforward, but requires a lot of attention to detail, as you need to use the parameters to create new object credentials, create a new HTTP request, and other objects before the connection can be established. Each phase of the Guacamole implementation underwent testing. The solution selection phase had stress testing, and the plugin development phase had black box testing while trying to integrate it into the main Guacamole application. Unit testing and integration testing were also used. The default Guacamole installation requires you to log into it. Once you log in, you are presented with your list of preconfigured remote desktops. What the Guacamole auth URL allows you to do is to set up a connection string with the authentication parameters of the remote desktop included. Then, you place that string directly into the address bar and you are able to start the RDP session. The Guacamole installer for VLabs consists of 2 scripts and a set of configuration files. The Guacamole VLabs installer script installs all the prerequisite software, downloads the Guacamole archives, builds the Guacamole application and the Guacamole plugin, and installs them. The script asks you to confirm if you want to download the prerequisite software. Then, use the Guacamole property script to copy all the configuration files into the required locations. After that, you have a working Guacamole server pre-configured for virtual labs.